This was an article that appeared in the Journal of Irreproducible Results some time ago, and it's called Cooking with Potential Energy. And I'm going to read some of this to you because I know you can't really see it very well, but it's well worth taking the time to look at it. So let me try to make it as big as possible. Okay, well, that might do it. Okay, so here's how it reads. It says, the world's supply of combustible energy resources, such as wood and fossil fuels, are rapidly diminishing. If civilization is to continue, we must quickly develop alternative non-combusting energy sources that can be used for basic human needs. Heating, transportation, and cooking will be of paramount concern. This new energy must be cheap, safe, and of such low technology that it can be easily understood by the layman. The obvious solution to any future energy crisis is the development and the use of potential energy. This form of energy is ubiquitous in nature, it's renewable, and to date it has been largely untapped. So all elevated objects possess potential energy. When an object is dropped from a height, its potential energy is converted into kinetic energy. Upon impact with the ground, this kinetic energy is converted into heat. This phenomena may be described using this equation that they give here. Now, if the change in height, delta Z, can be made sufficiently large, significant amounts of heat can be generated, and everyday tasks, such as cooking, could be made safe, simple, and energy efficient. In our experiment, we proved this can be done. In 6 hours, we partly cooked a 25-pound turkey with potential energy. So here are the materials and methods. There was considerable debate among the investigators as to what we should cook. A goose was suggested, but we finally settled on a 25-pound defrosted grease-ball brand turkey. At 9 o'clock in the morning, an undergraduate carried the bird up the stairs to the 10th floor of the University of Southern Arizona Administration Building. From this vantage point, he flung the bird from a ledge. Immediately after the turkey impacted on the pavement, the investigators inserted a thermometer into the carcass and recorded the temperature. The assistant then ran back down the stairs and retrieved the bird. This process was repeated 72 times in 6 hours with the same turkey. And they give you the data here in the form of a scatter plot. And what does this scatter plot show us? They said that they fit a least squares line, right? And they're showing us in the cooking time, this is the hours into the experiment, and they're showing us what the temperature of the turkey was at each time, right? But they fit a least squares line to it, so that line is going like this. It looks like see, they're ignoring the curve in the data that says that it's not getting any warmer. And they fit a least squares line, so it looks like by the time, well, they tell you, a least squares fit method was used. The rate of temperature increase for the turkey was 8 degrees Fahrenheit per hour. 8 degrees Fahrenheit per hour is the slope of the regression line, straight line regression line. So they go on to say at 3 o'clock in the afternoon, the last of our funding was consumed, and by funding they're talking about $11.07 for the turkey and $1.93 for bananas that were periodically given to our assistant. So they used up all their resources. By extrapolating, so the experiment was ended because they had no more resources. They have no more bananas to give the research assistant. By extrapolating from our existing data, it was obvious that the turkey would have reached a temperature of 400 degrees Fahrenheit in approximately 46 hours. While this is admittedly a slow cook, our critics would have to concede that we didn't burn any fuel. Actually, that's not exactly true because the research assistant burned a lot of fuel running up and down the stairs. The principal investigator sampled some of the partly cooked bird. He found it was somewhat cool, but comparable to any of the cooking his wife has done at home. He also reported that the meat was very tender. So I hope that you appreciate this story as much as I do. What's very clear in it is that something that people do all too often. They don't look at the scatter plot, because if you had looked at the scatter plot, you would have seen that this bird got warmer initially and then wasn't getting any warmer. But because they used the wrong model, they extrapolated to a situation where they thought that in many, many hours the bird would have been cooked because they were incorrectly extrapolating out to the extremes.